Hello everybody, I would like to welcome you to our 8th video in the Pre-Algebra playlist. And in this video we are going to go over a very important concept of expressions and variables. Now when you learn about expressions and variables, think about yourself as stepping up in the ladder of mathematics. From now on, almost everything that you deal with will have variables and or expressions in them. So what really do I mean when I say variable? What is a variable? How do you define a variable? So here is a definition of a variable. A variable is a letter that is used as a replacement for a number. So basically, one of the best ways to think about a variable is to think about the concept of pronouns in English. What we do with pronouns is that we use a similar technique of that of variables. For example, if I say something like Ivan went to school, and then in the next sentence, if I say something like Ivan went to the market, and in the third sentence, if I say something like Ivan loves to go out of the country, you might be getting tired of hearing the words Ivan, Ivan, and Ivan again and again. So what you do is that you replace the word Ivan with the word he. Instead of writing Ivan and Ivan over again, in the next sentence I can just say he likes to go places. So, when we talk about variables, we're deploying a similar tactic to that of pronouns. Instead of writing a number, we choose a letter. One of the most common variable letters is an X. So let me give you an example of a variable in action. By now, you probably heard of the distance formula, and it goes something like distance is equal to rate times time. One of the uses of this formula is obviously to figure out how much of a distance was covered in a particular time given a particular rate of travel. So if I say I traveled for 1 hour at a rate of 60 miles per hour, I would have traveled 60 miles in that hour. So what mathematicians like to do is that they like to assign a letter to each word in the formula so that it is simplified when you keep on writing it over and over. In most cases, the letter that they assign is the first letter of the word. So they assign the word distance the letter D. They assign the word rate the letter R, and they assign the word time the letter T. In most cases, the letter assigned will be a lowercase letter. So instead of writing the distance formula every time as the whole word distance equals rate times time, I can simply write D equals R times T. If I want to go a step further and simplify it even more, I can simply get rid of the dot and put the R and the T together. It is understood that when you have two letters next to each other, such as this over here, you are implying the operation of multiplication in mathematics. Now, this is only implied if both of those letters are variables. In this case, both R and T are variables. On the next page, I would like to go over something called a variable expression. So what do I mean when I say a variable expression? Well, variable expression is defined as a phrase that uses operation symbols, variables, and numbers. So what do I mean by this? Well, let me give you a few examples of what a variable expression is, and then you'll get a better hang of it. One of the examples of variable expressions is this right here. X minus 10 is an example of a variable expression because it uses a variable x, it uses operation symbol of the subtraction, and it uses a number such as the 10. Now, what x minus 10 represents is really unknown. It could represent any number of things, but for the purposes of this video, it's not relevant. Another example of a variable expression is this right here. 5 plus y is an example of a variable expression. Another example of a variable expression is this right here. This right here is read as 11 times k. Now, you may not see a operation symbol over here, but it is implied that the number 11 and the variable k are being multiplied to each other. So anytime you want to say that a variable is being multiplied by another variable or another number, all you need to do is simply put the variable right after the number. Or if you're multiplying two variables together, it doesn't matter which variable goes out in the front. And finally, another example of a variable expression is this right here. 6 divided by a. In this case, the operation symbol is the division, the number is the 6, and the variable is an a. So now that you know and you can identify what a variable expression is, I would like to go over something called a numerical expression. Now, a numerical expression is similar to a variable expression, but a numerical expression does not have a variable in it. So, a numerical expression is defined as only containing numbers and operation symbols. So now let me give you a few examples of what a numerical expression looks like. First of all, a numerical expression could look like this over here. Something as simple as 5 minus 4 is called a numerical expression because it contains numbers 5 and 4 and an operation symbol of the subtraction. Another example of a numerical expression is like this over here. In this case, you have two different operation symbols. But that doesn't mean that the expression is not a numerical expression, because according to the definition, there is no specification on how many symbols or how many numbers there can be. And I think you get the hang of it by now, so I'll do one more example of a numerical expression. Something such as 11 times 12 plus 6 divided by 2 is an example of a numerical expression. Another important skill that you need to know is how to convert a variable expression into words and convert words into a variable expression. But before we begin, there are a few words that are used commonly in mathematics that I would like to go over with. And every time you hear those words, you should either think about addition, subtraction, multiplication, or division. So think about the words that I'm going to write down over here as your toolkit. Every time you hear these groups of words, think about their respective operation symbols. So anytime you hear the words more than, greater than, increased by, larger than, or total, or something to that extent, think about the operation symbol of addition. Similarly, if you hear the words difference, less than, smaller by, decreased by, fewer than, or any other words to that extent, think about the subtraction symbol operator. On the next page, I will go over the few words that represent the multiplication operator and a few words that represent the division operator. If you ever hear the words product, times, increased by a factor of, or anything to that extent, think about the operation multiplication. And lastly, if you hear the words average, quotient, divided by, etc., think about the division operation. Now in the last part of this video, I would like to go over a few examples in which we convert variable expressions into word phrases and a couple examples in which we convert word phrases into a variable expression. In this first example, let's say I want to convert the variable expression x plus 11 into a word phrase. The best way to approach these problems is to take it step by step. I realized that I have three parts in this problem. The first part is the variable x. After that, the second part is the addition operator, and then the third part is the 11, which is the number of the problem. So if I want to say x plus 11 into words, I refer back to my toolkit and I can replace the addition symbol with the words more than. Therefore, one way of writing x plus 11 is to say 11 more than the number x. In this example, let's say I want to convert 9 times k, or just simply 9k, into words. So I realized that in this variable expression, my number is 9, my variable is k, and the operation is the multiplication. So if I want to write 9k into words, I can say something like k times the number 9. In this third example, let's say I want to write b divided by 5 into words. First of all, I can simply rewrite this notation over here into a fraction form like this over here. But for the purposes of this video, let's just focus on this part over here. So if I want to write the variable expression b divided by 5 into words, I can write it as something like a number b divided by 5. In this fourth example, let's say I have j minus 5. I can write the variable expression j minus 5 into words by simply writing 5 less than the number j. But if I had something like 5 minus j, I will have to write this variable expression over here into words as j less than the number 5. So there it is. I think by now you have a pretty good grasp of how to convert a variable expression into words. Now let's do two examples in which we convert words, or basically word problems, into an appropriate variable expression. So here is the first word problem that we will convert into a variable expression. So here is a problem. Best friends Amber and Taylor are always together. If Taylor is 7 inches taller than Amber, how tall is Amber in inches? Now, before we begin the solution to this problem and figure out a variable expression to represent this word problem, I would like to tell you something about variables. Variables are used when you have an unknown in your problem. In this case, there are two unknowns. In the first unknown, we don't know how tall Amber is. Our second unknown does not seem like an unknown, but if you think about it, we don't really know how tall Taylor is either. So, the heights of best friend Amber and Taylor are the two unknowns in this problem. Now, let's assign variables so that our lives become a little bit easier. One of the other important things that you need to know when you're writing word problems into variable expressions is that every time you hear the word is, you should replace the word is by an equal sign when you write out your variable expression. In this case, we will be writing a variable equation because of the involvement of an equal sign. Now, let's get to the solving part of the problem. What we want to know is how tall Amber is. Now, let me write a question over here. So, we need to have the variable a all by itself, because that is the thing that we want to identify. So we have the a variable on our left side over here. Then we write the equal sign right next to it. And then we move on to the height of Taylor. We know that Taylor is 7 inches taller than Amber. But since we want to employ the variable t over here, we can write t minus 7 on the right hand side to complete our variable equation. Now, does a equals t minus 7 sound like the right variable equation? Well, let's think about it. If a represents the height of Amber, the equals represent the equal, and t represents the height of Taylor, and then the minus 7 is simply the minus 7, we can read this out as Amber's height equals the height of Taylor minus 7 inches. And that is the condition that is given in the word problem. Our variable equation in this case is a equals t minus 7. Now let's do one more if you didn't really get the hang of it this time. So in this example, I have at Bernie's Beautiful Bakery, each donut costs 50 cents. If Michael buys a few donuts at this bakery, how much money in cents did he spend? So, in this case, the first thing that we need to do is identify how many unknowns we have. The first unknown is that we don't know how many donuts Michael bought. This is because we only know that Michael buys a few donuts at this bakery. Now, the meaning of the word few could be 1, 2, 3, or in some cases even 50. So, that is the first variable that we need to assign. Now, you can pick any letter again, but since we're talking about donuts, I'm going to represent this variable by the letter D. The second unknown in this problem is that we don't know how much money Michael spent at this bakery. And again, you can assign any letter to this variable, but since we're talking about money, I'm going to choose the variable M. The first thing that we need to do is identify what is it that we are exactly trying to find. And according to this problem, the thing that we're trying to find is the money spent by Michael. So we need to isolate the variable of money all by itself, because that is the thing we are trying to find. So I write the M on my left hand side. Next thing I do is that I put an equal sign, and now on the right hand side I continue on with my solution. What I know for sure is that each of the donuts at Bernie's Beautiful Bakery cost 50 cents. And what I know is that Michael bought D amounts of donuts. So, do I need to write 50 plus D, 50 minus D, 50 divided by D, or do I need to write 50 times D? Now, if I write 50 plus D, this means that the money that Michael spent is equal to 50 cents plus however many donuts he bought. So, if Michael bought one donut, that is like saying that Michael spent 51 cents. Since that is not true, I know that I do not use addition in this problem. Now, if I say 50 minus D, that is the same thing as saying that the amount of money spent by Michael is equal to 50 cents minus however many donuts he bought. Now, logically, if you think about it, this means that if the D is bigger than 50, in this case, let's say Michael bought 100 donuts. So that would mean that the money that he spent is equal to 50 minus 100. So that means that if Michael bought 100 donuts, he spent negative 50 cents. Since this is not a logical statement, subtraction is not the right operation to use in this case. Now let's say we use multiplication. So I would do 50 times D. What this tells me that if Michael bought 2 donuts, he would end up spending 100 cents. And this does really make sense because if he bought 2 donuts, he would spend 50 cents for each donut, equaling 50 plus 50, which equals 100 cents. Now let's just make sure. Let's say Michael bought 3 donuts. If Michael bought 3 donuts, that's like saying he spent 50 plus 50 plus 50 cents. And that is equal to 150 cents. So, if Michael bought 3 donuts, that's the same thing as saying 50 times 3 according to the equation that we found over here. And since 50 times 3 is also equal to 150, we know that we have reached the correct variable expression, or in this case, the correct variable equation for our problem. So our answer is m is equal to 50 times d. So now that you got the hang of variable expressions and what it means for something to be a variable, you have just taken a really big step in your mathematical careers. From now on, almost every chapter, every video, every lesson, test, or whatever that you take will include some sort of a variable in it. So I hope you enjoyed this video and you learned a lot from it, and I hope you keep on working hard, and I'll see you in the next video.